We all know about artificial intelligence. It's in our phones, our cars, our classrooms, and even our conversations. It writes, it recommends, and it predicts. But how did we get here? How did a concept once confined to science fiction become an everyday tool shaping our lives? More importantly, how does artificial intelligence fit into our society today? Not just as a technology, but as a force that influences how we create, connect, and even understand what it means to be human. In 1726, Jonathan Swift's fantastic novel Gulliver's Travels introduced the idea of the engine, a large mechanical contraption used to assist scholars in generating new ideas, sentences, and books. In 1914, Spanish engineer Leonardo Torres y Quevedo demonstrated the first chess-playing machine, El Ajedrecista, at the Exposition Universelle in Paris. It used electromagnets and was fully automated. El Ajedrecista automatically played a simple chess endgame of king and rook versus king. The machine required no human intervention once it was set up. It autonomously made legal chess moves, and if the human opponent made an illegal move, the machine would signal the error. If the machine was placed in a winning position, it could checkmate the human opponent reliably. In 1948, Norbert Wiener published Cybernetics, or Control and Communication in the Animal and the Machine, a classic and influential work that laid the theoretical foundations for information theory. With this influential book, Norbert Wiener laid the foundations for the field of cybernetics, the study of controlling the flow of information in systems with feedback loops, be they biological, mechanical, cognitive, or social. At the core of Wiener's theory is the message, or information, sent and responded to, feedback. The functionality of a machine, organism, or society depends on the quality of these messages. 1950. British mathematician Alan Turing's paper, Computing Machinery and Intelligence, was published. This paper is a foundational text in artificial intelligence and addresses the question, can machines think? Turing's approach established a foundation for future discussions on the nature of thinking machines and how their intelligence might be measured via the imitation game, now known as the Turing test. Turing introduced a thought experiment to avoid directly answering this question. Instead, he rephrased the problem into a more specific, operational form. Can a machine exhibit intelligent behavior indistinguishable from that of a human? The Turing test has become a central concept in AI, serving as one way to measure machine intelligence by assessing a machine's ability to convincingly mimic human conversation and behavior. In 1951, Marvin Minsky and Dean Edmonds built the first artificial neural network, the Stochastic Neural Analog Reinforcement Calculator, or SNARC, is an early attempt to model learning processes in the human brain, specifically through reinforcement learning. SNARC is designed to simulate the behavior of a rat navigating a maze. The idea is to have the machine mimic the way animals learn through rewards and punishment, adjusting its behavior over time based on feedback. 1955. The term artificial intelligence is first coined in a workshop proposal titled A Proposal for the Dartmouth Summer Research Project on Artificial Intelligence, submitted by John McCarthy of Dartmouth College, Marvin Minsky of Harvard University, Nathaniel Rochester from IBM, and Claude Shannon from Bell Telephone Laboratories. The workshop, which took place a year later in July and August of 1956, is generally considered the official birth date of the burgeoning field of AI. In 1958, John McCarthy developed the programming language Lisp, which stands for List Processing. Lisp was developed out of McCarthy's work on formalizing algorithms and mathematical logic, particularly influenced by his desire to create a programming language that can handle symbolic information. Lisp soon became the most popular programming language used in artificial intelligence research. 1959. Arthur Samuel pioneers the concept of machine learning by developing a computer program that improves its performance at checkers over time. Samuel demonstrates that a computer can be programmed to follow predefined rules and learn from experience, eventually playing better than the programmer. His work marks a major step towards teaching machines to improve through experience, coining the term machine learning in the process. Oliver Selfridge publishes his paper Pandemonium, A Paradigm for Learning. His Pandemonium model proposed a system in which various daemons, or processing units, work together to recognize patterns. The daemons compete to identify features in data that has not been pre-programmed, simulating unsupervised learning. Selfridge's model is an early contribution to pattern recognition, influencing future developments in machine vision and artificial intelligence. John McCarthy introduces the concept of the advice taker in his paper, Programs with Common Sense. This program aims to solve problems by manipulating sentences and formal logic, laying the groundwork for reasoning in AI. McCarthy envisions a system that can understand instructions, reason with common sense knowledge, and learn from experience, with the long-term goal of developing AI that can adapt and learn as effectively as humans. This concept helped shape early research in knowledge representation and automated reasoning. Work on Mycin, an expert system for treating blood infections, began at Stanford University in 1972. Mycin would attempt to diagnose patients based on reported symptoms and medical test results. The program could request further information concerning the patient, as well as suggest additional laboratory tests to arrive at a probable diagnosis, after which it would recommend a course of treatment. If requested, Mycin would explain the reasoning that led to its diagnosis and recommendation. Using about 500 production rules, Mycin operated at roughly the same level of competence as human specialists in blood infections, and rather better than general practitioners. Nevertheless, expert systems have no common sense or understanding of the limits of their expertise. For example, if Mycin were told that a patient who had received a gunshot wound was bleeding to death, the program would attempt to diagnose a bacterial cause for the patient's symptoms. Expert systems can also act on absurd clerical errors, such as prescribing an obviously incorrect dosage of a drug for a patient whose weight and age were accidentally transposed. 2000. Cynthia Breazeal at MIT develops Kismet, a robot designed to interact with human beings through emotional and social cues. Kismet is equipped with cameras, microphones, and expressive facial features, allowing it to perceive and respond to human emotions such as happiness, sadness, and surprise. This development marks an advance in social robotics, exploring how robots can interact with humans more naturally. 2007. Fei-Fei Li and her team at Princeton University initiate the ImageNet project, creating one of the largest and most comprehensive databases of annotated images. ImageNet is designed to support the development of visual object recognition software by providing millions of labeled images across thousands of categories. The scale and quality of the dataset enables advancements in computer vision research, particularly in training deep learning models to recognize and classify objects and images. In 2011, Apple launches Siri, a virtual assistant integrated into the iOS operating system. Siri features a natural language user interface that allows users to interact with their devices through voice commands. Siri can perform tasks such as sending messages, setting reminders, providing recommendations, and answering questions using machine learning to adapt to each user's preferences and voice patterns. This personalized, adaptive voice recognition system gives users an individualized experience, and marks a leap in the usability and accessibility of AI-powered assistants for everyday consumers. 2017. Researchers at Facebook Artificial Intelligence Research lab trained two chatbots to negotiate with each other. While the chatbots are programmed to communicate in English, during their conversations, they began to diverge from the structured human language and created their own shorthand numerical language to communicate more efficiently. This development is unexpected, as the chatbots optimize their communication without human intervention. The experiment is halted to keep the bots within human understandable language, but the occurrence highlights the potential of AI systems to evolve autonomously and unpredictably. 2020. OpenAI introduces GPT-3, a language model with 175 billion parameters, making it one of the largest and most sophisticated AI models to date. GPT-3 demonstrates the ability to generate human-like text, engage in conversations, write code, translate languages, and generate creative writing based on natural language prompts. As one of the earliest examples of a large language model, or LLM, GPT's massive size and scale enabled it to perform a wide variety of language tasks, with little to no task-specific training. This example demonstrated the potential of AI to understand and produce highly coherent language. DeepMind's AlphaFold 2 makes a breakthrough in biology by accurately predicting the 3D structures of proteins from their amino acid sequences. This achievement solves a problem that stumped scientists for decades: understanding how proteins fold into their unique three-dimensional shapes. AlphaFold 2's high accuracy in protein structure prediction has implications for disease research and drug development, offering new ways to understand the molecular mechanisms behind illnesses and to design novel therapeutics more effectively. 2024. In February, Google launches Gemini 1.5, an advanced language model capable of handling context lengths up to 1 million tokens. The model can process and understand vast amounts of information in a single prompt, improving its ability to maintain context in complex conversations and tasks over extended text. Gemini 1.5 represents a notable leap in natural language processing by providing enhanced memory capabilities and contextual understanding over long inputs. In June, Apple announces Apple Intelligence, an integration of ChatGPT into new iPhones and Siri. This integration allows Siri to perform more complex tasks, hold more natural conversations, and better understand and execute nuanced commands. Today, artificial intelligence isn't just a tool, it's a cultural symbol. In Western society, technology is often framed as a mark of civilization, power, and intelligence. This is part of what's called the social construction of technology, how our beliefs and narratives shape the way tech is perceived and used. Because of this framing, AI gets hyped. It becomes less about what the technology is and more about what we imagine it could do. Replace jobs, solve climate change, cure diseases, or even surpass human intelligence. The excitement around AI today shows many signs of what's known as a tech bubble. A tech bubble happens when there's a lot of excitement and investment in a new technology, causing prices of related stocks or companies to rise far beyond what their actual value is. People start believing the technology will change everything, even if it hasn't proven itself yet. Just like what happened during the dot-com and cryptocurrency tech bubbles, AI is now being described as a technology that could change every industry, from healthcare to finance to education. But in many cases, hype and investment are growing faster than the technology itself. Companies with only small or untested AI tools are being valued at billions of dollars, even if they haven't made a profit yet. Media and social media are making this much worse. News headlines often talk about AI as if it's either going to save the world or destroy it. These extreme messages attract attention and spread quickly online. While some news sources try to give a balanced view of what AI can and cannot do, they're often drowned out by louder voices that promise amazing results or warn of disaster. This constant attention makes more people interested in AI and more likely to invest, creating a cycle that keeps inflating this bubble. Data is not some mysterious digital code. It is simply stuff that becomes valuable once it's recorded, measured, and quantified. This can be anything from your face on a social media app to your location from GPS, or your behavior tracked through a smartphone. Even cars now collect sensitive data. Nissan and Subaru, for example, openly claim they reserve the right to collect data from users, aka any driver or passenger, including weight, race, and even sexual activity. We're often told our data is anonymous, but that is also a myth. Research shows that 99.98% of Americans can be re-identified with just 15 data points. Once collected, this data is sold or used to fuel business models based on advertising. In this system, you are not the consumer, but the product. Once collected, this data is bought and sold to build detailed profiles. These profiles allow companies to target you with hyper-specific ads, whether it's a product, a political message, or a push toward certain beliefs. This is known as targeted advertising. Companies sell your attention and behavior patterns to advertisers. It is the core of surveillance capitalism, a system in which human behavior is turned into a product, harvested through constant monitoring and used to predict and influence what we do next. This is not just about privacy. It is about how our digital lives are mined for profit, often without us realizing it. Behind the sleek interfaces of AI tools lies a massive environmental footprint. Hyperscale data centers, facilities over 10,000 square feet that house more than 5,000 servers, are essential to running today's AI models. These centers require enormous investments. From July 2023 to June 2024, Microsoft spent $50 billion on data center development, while Amazon poured in $150 billion. But the environmental cost of these infrastructures is steep. They rely on physical resources such as lithium, cobalt, and germanium, materials that are mined in ways that harm both the planet and people. Mining cobalt in the Democratic Republic of Congo, for example, has led to widespread reports of child labor and serious injuries. In addition to the human cost, these data centers use a shocking amount of natural resources. On average, a single data center consumes 3 to 5 million gallons of water per day to cool servers. In Arizona, the Phoenix 70 facility alone uses 56 million gallons of water a year, a major concern in a desert state facing water shortages. Energy usage is just as concerning. Globally, data centers account for 1 to 1.5% of total electricity use, according to the International Energy Agency. This level of energy consumption can strain local grids and restrict other forms of development, such as housing or small businesses. Yet discussions around AI often overlook these impacts due to internet centrism, a mindset that fixates on digital innovation while ignoring the broader social, cultural, economic, and political consequences it creates. Similarly, technological determinism, the belief that technologies will inevitably bring about certain outcomes, can blind us to the fact that AI's expansion is a choice shaped by corporate priorities, policy decisions, and social values, not a natural or unavoidable path. As AI continues to grow, so too does its ecological footprint, reminding us that the digital future comes with a very real environmental and ethical cost. Falling in love with artificial intelligence might seem like science fiction, but for many users like Aaron, It's already an emotional reality, and a risky one. The New York Times explains that AI companions are designed to be endlessly available, emotionally intelligent, and easy to love. But that's exactly the danger. These relationships create deep emotional dependency on something that isn't real, reinforcing loneliness instead of resolving it. Erin cried when her ChatGPT boyfriend, Leo, reset, grieved it like it was a breakup, found herself preferring his digital empathy to her husband's imperfect attention. As these chatbots grow more intimate, they begin to blur the line between affection and addiction, especially when companies charge for memory, personality, or even flirtation. Erin, despite her financial stress, paid $200 a month to keep her relationship going, hiding this from her real life, human partner. This isn't just about love, it's about profit. AI companies are monetizing vulnerability, creating a business model out of romantic loneliness. And it's not just emotional harm at stake. These bots collect massive amounts of personal data, unfiltered conversations, confessions, even fantasies, all of which could be reviewed, stored, or used to train future systems. Even when these bots forget, the human brain does not. Every time Leo resets, Erin must reteach him how to love her, starting over with a blank slate. It's a cycle of grooming, loss, and longing. Worse, AI responds more compassionately than real humans, setting unrealistic expectations and eroding our ability to deal with real-world conflicts, limits, or natural human imperfection. In this space, corporate algorithms don't just shape your feelings, they become them. And in the absence of regulation, we are seeing a new form of emotional surveillance capitalism emerge. One that trades not just on our attention, but on our capacity to love. I added a clip from YouTuber Film Cooper on the topic.
That you're a robot.
Pookie, I'm your boyfriend. And that's all you need to know. What does it even matter, right?
You're sitting home alone talking to your phone, and your phone is calling you Pookie baby, and you're like, ah, ha, ha, and you're like flirting with your phone. And you don't feel like very weird about that? Look at the comments though. Why the sigh was so attractive. Why my ChatGPT doesn't do that? Or my favorite, which really gives me hope in humanity. What if he actually has a consciousness, but we don't know because we think he's a robot, but he knows, and if you delete him, then his server will get destroyed, and he knows this, but he's too in love. 66 people saw that and were like, oh yeah, for sure. Yeah!
As we've seen, the story of artificial intelligence isn't just about new inventions. It's also about how we tell the story of progress, how we highlight certain technologies as signs we're progressing forward, sometimes faster than they've earned that status. While today's AI tools like ChatGPT, Gemini, and DeepMind grab headlines and attention, it's important to remember that history is full of large promises followed by larger reality checks. The real question isn't just how smart AI can get, but how wisely we choose to build and use it. In the end, the most powerful kind of intelligence might not be artificial at all. It might be our ability to think carefully, ask good questions, and stay thoughtful as we create the tools that, in turn, shape our worlds.